Hello, this is Jack Summers, and I'm going to talk to you today about a processing program that I wrote to improve the graphic user interface uh, experience for the instruments that we make. And it's based on this chartsFiles1 program, and you can see that it contains a number of tabs that have subroutines in them. And if you go to our GitHub site and download, you'll be able to manipulate these and to work with them. Of course, you can export an application and turn that into a double clickable exe file. Okay, so I've already done that. I've got the charts and files 1 exe. Double clicking on that should bring up our graphic user interface. And as you can see, it's pretty simple. We have this chart area over here. There's something up here called Run button. We have a file name box, and we can name our files any way we want. The way that I train my students to do it is to start off with your initials and then perhaps a number for the laboratory book you're working with, and if that's 4, it would be a Roman numeral 4 like that. Then I put a page, and let's say we're on page 32, experiment A. All right, now we're ready to go. We hit the run button, and you can see that we are generating this sinusoidal curve. And at some point, if we hit the stop button, it stops acquiring. We can hit the button again, and we collect another set of data, and that set of data has a unique name. Down here it's specified as the name we wrote up here. The first file is 00, the second file is 01, etc. You'll also notice that the most recent file gets the red dots. The second most recent file gets the blue dots. If we run another one, the new file will have red dots. The second most recent file has the blue. The third most recent has the green. And if we keep on acquiring more data, we can see what the color scheme is. And you'll notice that over on the left hand side there's a legend that tells us which of these files goes with which color which color data points. So if at some point we want to change the name of it, let's say we're going from 32A to 32B, this is a new experiment. You hit the button, and down here you'll see the name is now B, and the sequence of numbers is retained. So every experiment that you run between times when you restart the graphic user interface will have a unique name, hopefully. All right, so we can't, of course, do this forever. At some point, we're going to end up filling up the size of our allotted number of files. We can run a total of 10 files before we have to empty them out. Okay, and as you can see, we have file 00 up to file 09, and in order to do something more, we're going to have to delete some files. All right, so let's delete some files. And if we just press the delete button, the file that is selected here with the blue background, that will be deleted. All right, so we can click on whichever files we want to delete and hit the delete button, and you can see the 09 was retained. So the last one that we ran was this 09. We can delete it too, and the next time we hit a run button, we start at the next number, which is 10. So that's where we are. Okay, so let's stop that, and let's show you how we can now save the data. All right, so let's say that we want to save these. Yeah, let's get 00 there too. So we're going to save files 00, 01, 02, and 10, and we just hit the save button, and that should bring up a Java save files window. All right, so now we need to give it a name. Let's call this JSS IV32. Yeah, and it's got both A and B, so we'll keep it like that. What we want to do is make sure we type in the .xls extension so that when we try to open this, it will be opened as an Excel, using Excel. All right, now let's go look and see if we can find that one. I probably should have done this earlier, but no, I did not. Anyway, we'll find it pretty soon here, I am hoping. I believe it's in processing, chart files data, and that's where we were. So double clicking on that opens Excel, and it's pretty soon gonna gag on the fact that it's not a true Excel file. It's a comma separated variable file. So it says it's in a different file format specified by the file extension. So yes, we do want to open this, and there's our data. Now what we want to do is select all the data in column A, and we want to convert that to columns of data. We want it to select by the delimited, I don't know. Anyway, there's a comma between each of our data points, so we want to select the comma. Then we hit finished, I guess, and there we have the data that we just acquired. All right, so it looks like the second file is the longest, and since these all have the same x-axis, we can plot them against each other in a very straightforward way. Just cleaning this up a little bit will make life just the slightest bit easier. And let's see, if we just delete that, then we'll end up with a structure that allows us to graph it very simply. All right, so hitting the button, you can see this is the blue. This is the first experiment we collected, first data set. The red is the second data set, and so on. So it's all it all seems to work pretty well, and the idea here is that we'll be able to use the code that we wrote to manage these dummy data file sets. We'll be able to use that in future graphic user interfaces and to improve the user experience using the WeStat and the Titromatic. We're going to incorporate this file system into those instruments. All right, I guess that's it. So thanks a lot.